Hi, this is Dave Johnson with another edition of Math Off Topics. This is the third video in a three-part series. The first was on square root conjugates. The second was on cube root conjugates, and this one is on trig conjugates. You probably have seen the trig conjugate method in your pre-calculus or trigonometry course, but I wanted to do a special video on this just to make sure that you saw it in the context of limits and maybe to solidify what we had talked about in the other two videos. By the way, I will include links to those other two videos in the show notes below. So let's get into it. So I have in mind doing a limit as x goes to 0 of 1 minus cosine x over x. And first, let's realize that this is, let me copy, make another copy so we can start with a fresh copy. Obviously, this is going to be indeterminate. If you plug in 0 for x, cosine of 0 is 1. 1 minus 1 is 0. And so you have 0 upstairs and certainly a 0 downstairs. So you get 0 divided by 0, which is indeterminate. And so when you ever see 0 divided by 0, you can't just put a box around it and call that the answer. Your calculus teacher will not be happy with that. You need to do more work and figure out what the 0 divided by 0 indeterminate form actually equals, or whether it exists at all. So let's do that. Hopefully the trig method using conjugates will work. If we think about why is it a conjugate method, well, you got an a minus b here. The a is 1, the b is cosine x, and so that looks suspiciously similar to what we saw in both of the other two videos. If you have an a minus b that's causing an indeterminate form, maybe you can multiply top and bottom by something that will get rid of the a minus b. And so we can do that. Let me remind you that 1 minus cosine x times 1 plus cosine x. Okay, so a minus b times a plus b. Well, that's going to be a squared minus b squared, but that's just going to be 1 minus. So a squared is 1, and then b squared is cosine squared of x. And if you remember from your trigonometry, 1 minus cosine squared x is sine squared x. That's what we call the Pythagorean identity, one of the forms of the Pythagorean identity. So if we multiply top and bottom by 1 plus cosine x, so let me rewrite this limit as x goes to 0 of, so upstairs we're going to get sine squared x, and downstairs we're going to get x times 1 plus cosine x. You can't forget that 1 plus cosine x, which is still downstairs. We had to multiply top and bottom by that expression. We still have our x and we still have our 1 plus cosine x. But now we have a sine squared x upstairs. Okay, what do we do? Well, look at it and it's still indeterminate, right? Because if you plug in 0 for x, upstairs you get sine of 0 is 0, so 0 squared is 0. So you got a 0 upstairs, you got a 0 downstairs. It's still indeterminate. But maybe we can rewrite this. Remember, always be in your mind thinking about all the limit theorems that you know, the various limits that you've learned. One of the limits that you probably have learned by now is the sine x over x limit. And so we can rewrite this in terms of sine x over x. So let me just do that. So limit as x goes to 0. So I'm going to write this as sine x over x, but then we have to multiply that by another sine x divided by 1 plus cosine x. Whenever you factor something like this, you should check to make sure that your factorization is correct. Upstairs, we have sine times sine, which is sine squared. Downstairs, we still have our x times 1 plus cosine x. So everything looks cool. But now we're taking the limit of a product, and the limit of a product is the product of the limits. That's one of the limit theorems that we've learned. So I can rewrite this as limit as x goes to 0 of sine x over x times the limit as x goes to 0 of sine x over 1 plus cosine x. Again, the limit of a product is the product of the limits. And so I've simply written this limit, which is the limit of a product, as a product of two limits, this limit times this limit. Okay, so, but we recognize that this limit is what? Well, it's 1, because the limit is x goes to 0 of sine x over x. Another way to think of this limit is the small angle approximation for sine. So sine x is approximately equal to x if x is small, and it becomes exactly x as x goes to 0. So the ratio is going to be 1. So that limit is 1. So we get 1 times this limit. But when you plug x equals 0 upstairs, you get 0. Downstairs, you get, well, cosine of 0 is 1. 1 plus 1 is 2. So 0 divided by 2. But 0 divided by 2 is 0. And so that's our answer. Now, there's many different forms that this problem can take. You could have 1 minus sine x. You could have, different forms that might all involve the Pythagorean identities in some way, or other trig identities. But I wanted to illustrate this with a simple example in the part 3 of this series. I hope this has been helpful. If it has, subscribe if you haven't already, and give this video a like if you feel it's worth it. Thank you so much, and see you next time.